Question 8 from Chapter 4 homework asks us to write the balanced molecular equation for the reaction in aqueous solution from ammonium sulfate and iron 2 chloride. So this is question number 8. And we can write it out, but we also want to analyze the table for solubility data. So ammonium is NH4 plus, sulfate is SO4 2 minus. So that means I need 2 ammoniums to balance out the charge on sulfate. That is in solution, aqueous solution with iron 2 chloride. So if iron is 2 plus, I would need 2 chlorides at -1 each. And it asks us to predict the product of that reaction. And just to take a look and to hypothetically go through that, we can do that, right? This would be a metathesis reaction, so we would swap partners. And so I'll rewrite it to show the different colors that'll come together, so to highlight the different molecules that would combine. So I'm going to erase the sulfate, and I'm going to erase the iron. And I think it'll be a little bit easier to see the potential products, right? So there's my sulfate, SO4, and there's my iron. So the possible products from this reaction would be the sulfate coming together with the iron and the ammonium coming together with the chlorine. So one possible product would be iron 2 sulfate, FeSO4. And another possible product, right? Iron is 2 plus, sulfate is 2 minus, so they balance out completely. The other possible product from this reaction would be ammonium chloride. And I would have 2 of those because this subscript 2 would come out front and become a coefficient. This subscript 2 in front of the next to the chlorine would also come out and become a coefficient because chlorine is -1 and ammonium, NH4, is +1. So they would balance out and I would have 2 of each of those. So those are my potential products. And it's asking me, does a reaction occur? Does a precipitation reaction occur? So to answer that question, we want to look at this chart and see where each of these ions shows up. And really, we don't need to go any farther than this right there. And basically what that means is, and we can also look at the sulfate, and we can look at the chloride, right, to answer this question. Iron doesn't show up. So what this chart is telling you is that anything that forms with ammonium, right? Any ionic compound that forms with ammonium will be soluble. So ammonium sulfate is soluble. Iron sulfate, right? Ammonium chloride is also soluble. So ammonium sulfate is soluble because any compound containing ammonium is always soluble. There are no exceptions. So that means ammonium sulfate is soluble, and ammonium chloride is also soluble. So far, nothing's precipitated to leave reaction. Chlorides, right? Anything that silver, mercury, or lead are the only thing that would precipitate with chloride. So iron chloride, iron 2 chloride is soluble, ammonium chloride is soluble. Sulfates, the only time sulfates would precipitate, right? All sulfates are soluble except for silver, calcium, strontium, barium, and lead. We have iron. So iron sulfate is also soluble. So because this is soluble, this is soluble, this is soluble, and this is soluble, there is no reaction. Right? In order for a reaction to occur, you would need to have a reason for this exchange to take place. So if something was precipitating, if one of these products precipitated from solution, then yes, that would force a reaction to occur because, let's say hypothetically, the iron sulfate precipitated. If that left solution, right, then that would force the ammonium and chloride to come together to form ammonium chloride. So there is no reaction in this case because everything is soluble. There is no precipitation that would occur. Because there's no precipitation, there's no driving force for a reaction. There's no reason for ammonium sulfate to switch partners with iron chloride, forming iron 2-sulfate and ammonium chloride. So simply, we can just write no reaction for this question. And we can use that data table to confirm that everything, both starting reagents and both potential products, will be soluble in solution.